Next problem. Three different machines are used for production. On the basis of outputs, set up one-way ANOVA table and test whether the machines are equally effective. Given that the value of f at 5% level of significance for 2,9 degrees of freedom is 4.2926, that is the tabulated value. Given total number of items 12, R is number of machines, that is equal to 3, then number of technicians, so number of outputs, right, of each machine, and that is C1, C2, C3, all are equal, that is equal to 4. So null hypothesis, there is no significant difference, right, in the output of each machine. So H1 alternate hypothesis, there is significant difference, right. So now shift the origin to 10. So we are rearranging the table. So subtract 10 from each number of the given data. So 10 minus 10, 15 minus 10, machine 1, right. Similarly, machine 2, machine 3, subtract 10. So you will get new table. So using that table, we are going to calculation for an ANOVA table. So machine R is equal to 3, 1, 2, 3, and outputs C is equal to 4, 1, 2, 3, 4. Then write the new number after shifting the origin, right. Then first row 1 total, row 2 total, and row 3 total. 6 minus 13, 20. Sum of the row totals, grand total, that is G is equal to sigma Ri, that is equal to 13. Then find Ri square by Ci. So R1 square by C1, so 6 square by 4, 9. R2 square by C2 minus 13 square by 4, 42.2. Then 20 square by 4, that is equal to 10. Sum of Ri square by Ci, that is equal to 151.25. Next sum of square of each rows, right, SS. Summation xij square. So 0 square plus 5 square plus 1 square plus 0 square, that is equal to 26. Next row squaring, minus 1 square plus minus 3 square plus minus 5 square plus minus 4 square, 51. Then last row 10 square plus 6 square plus 0 square plus 4 square, 152. Adding all the sum of squares, so you will get summation sum of xij square, that is equal to 229. Then correction factor is equal to g square by n, that is equal to 14.083. Next total sum of square formula SS minus CF, that is equal to 229 minus 14.083, that is equal to 214.92. Next sum of square between the sample, that is equal to summation Ri square by Ci minus correction factor. So 151.25 minus 14.083, that is equal to 137.17. Sum of square within sample WSS, TSS minus BSS. So 214.92 minus 137.17, that is equal to 77.75. Next ANOVA table, some source of variation between sample, within sample, sum of square between sample BSS, that is equal to 137.17, within sample WSS 77.75. Degrees of freedom V1 R minus 1, that is 3 minus 1, 2. V2 N minus R, 12 minus 3, 9. Then mean sum of square between the sample BSS by V1 137.17 by 2, that is equal to 68.59. Then mean sum of square within sample WSS by V2 77.75 by 9, that is equal to 8.64. So here 68.59 is greater than 8.64. So F ratio is MBSS by MWSS, greatest minus lowest, divided by the lowest. So that is equal to 68.59 by 8.64, that is equal to 7.94. That is the calculated value. Now we are going to compare with the tabulated value. So for the degrees of freedom V1 comma V2 2,9, so 5% level of significance Ft is equal to 4.26. So calculated value is greater than the tabulated value. 7.94 is greater than 4.26. Therefore the H0 is rejected. Thanks.